This example comes out of section 8.2. So we're going to be solving a system of equations. In this case, I'm going to use algebraic means, and for this one, I'm going to use elimination. So the system I've chosen here is a quadratic system, meaning it's two parabolas. If I was doing it graphically, I could do the same thing I did in my last example, which is graph the top one, graph the bottom one, make my windows big enough that I can see if and when they intersect. And I think you would find that there'd be 2 points of intersection, second trace intersect, enter, enter, enter. We're going to do it algebraically. So we're going to do elimination. The simplest by far, in fact, you need to eliminate y. Don't try to eliminate x, because notice you've got x squareds and x's, and it gets pretty messy if you try to eliminate x. You find out you've got a problem. But if you just subtract these equations exactly as they sit, the y will be eliminated. Y minus y is 0. 2x squared minus x squared is x squared. Minus 32x minus negative 10x. Be careful with the minus, but it's minus 22x. And then 137 minus 32 is 105. So I now have a quadratic that I can solve. If I'm not feeling comfortable about what numbers multiply to 105 and add to negative 22, which is totally understandable, just use the quadratic formula. Negative b plus or minus square root b squared minus 4ac over 2a on your formula sheet, and you will get two answers for x. One of those answers will be x equals 7, and one of those answers will be x equals 15. Same answers you get if you do factor it by saying, oh, what multiplies to 105 and adds to negative 22. X equals 7, x equals 15. But your question isn't done there, because remember, somebody asked you what are x and y. So if x is 7, I grab one of my equations and I stick a 7 into it and say, oh, okay, if x is 7, what does y equal? And again, go back to the beginning to one of your original equations and you'll find that y equals 11. So when x is 7, y is 11 is one of the points of intersection on that graph. I go over to 15 and I do the same thing. Stick 15 into one of the original parabolas, and either one should give me the same answer. That's why this is the solution, and I get an answer of y equals 107. So had I decided to do this question graphically, I would have had to have window settings at least big enough to see those points, but the good news here is I don't have to worry about that. We've done it algebraically, and if you're at all questioning your answers, try putting x equals 7, y equals 11 into either one of those two equations. Try putting x equals 15, y equals 107 into those two equations, and should be satisfied every time. So the main thing to remember in elimination with quadratic is eliminate y. You're trying to eliminate x squareds or x's, it's just going to make a big mess. Eliminate y, and you should head off into a direction of things that you solved in chapter 4.